Good evening, children. Good evening, online children.
Good evening, ma'am.
Good evening, Tanishka, Niveda, Keshav, and Ayavamai. Okay, I've shared my screen. Is it visible? Online children?
Yes, ma'am.
Yeah. Yeah, please write down the question. There is a question. The sum of the areas of two touching circles is 130 pi centimeter square. If the distance between their centers is 14 centimeters, find the radius of the circles. All right. So you can see here two touching circles. Two touching circles. You can see here two touching circles with centers O and O dash. With centers O and O dash. Okay. I've called this the point where the two circles touch. I've called that M. The point where the two circles touch. I've called that point M. OM is the radius of the first circle. O dash M is the radius of the second circle, R1 and R2 respectively. Okay. The sum of the areas of the two circles is 130 pi. Okay, that means pi R1 square plus pi R2 square is equal to 130 pi. All right, that's one equation. Then the distance between their centers is 14 centimeters. That means R1 plus R2. What is the distance between their centers? O dash. O dash is the distance between their centers. That means OM plus O dash M. This is O. This is O dash. This is M. Okay. O dash. O dash is equal to O dash is equal to 14 centimeters. That means OM plus O dash M is equal to 14. In other words, come, please. R1 plus R2 is equal to 14. All right. Okay. So we have two equations. The first equation is quadratic. You can see the first equation R1 square plus R2 square is 130. It's quadratic. Okay. And the second equation is R1 plus R2 is 14. It's linear. So use a substitution method. Write R1 in terms of R2 or R2 in terms of R1. Substitute that in the first equation. So you get a quadratic equation. Solve and find the two values of the unknown here, R2. Okay. And with the help of that, you can find R1 and hence the radius of the two circles. Yeah, please work. The question I've written on the presentation, you can see the answer over there. Please start. This is the first question. Is it? Completed? So since the sum of the areas of the two circles is 130 pi, pi r1 square plus pi r2 square is equal to 130 pi. Take out pi common and pi gets cancelled on both the sides. So we have r1 square plus r2 square is equal to 130. That's one equation. And then the distance between their centers is 14. O dash is 14. Or r1 plus r2 is 14. So since this is quadratic and this is linear, we are going to use a substitution method to solve. So we have written R1 in terms of R2. R1 is equal to 14 minus R2. You can also write R2 is 14 minus R1, whatever. Substitute that in the first equation. You get a quadratic equation and solve to find the two values of R2 and hence find the values of R1. Okay, next one. The question is not there. Just write the question here. This is the next one, children. The solution is what you see here. I'm writing the question here for you. Okay. So here two circles touch each other internally and the sum of their areas is 116 pi centimeter square. If the distance between their centers is 6 centimeters, find the radius of the two circles. So two circles that touch each other internally looks like this. Look like this. Okay. So the two circles touch each other internally at M. So you can see the centers of the two circles, O and O dash. O dash is the distance between the centers. O dash is the distance between the centers. And what is O dash? It is OM minus O dash M. What is O dash? O dash is 6, right? The distance between their centers, O dash is 6. So O dash is 6 means OM minus O dash M is equal to 6. What is OM? Radius of one circle. What is O dash M? Radius of the other circle. OM minus O dash M. OM is the radius of one circle or the bigger circle. O dash M is the radius of the smaller circle is equal to 6. Okay. And the first equation is the sum of their areas. Pi r1 square plus pi r2 square. Sum of the areas of the two circles. Pi r1 square plus pi r2 square is equal to 116 pi. As we did the earlier one, pi common, pi gets cancelled. Same method. Okay, got this? Completed? Yeah. Found R1? No. Well, that means you're blindly copying. Found R1? Yeah. No, that was hidden. I just scrolled down. Finished? Yeah, please finish. Online children completed?
Yes, ma'am.
Okay. Any questions? All right. Okay. I told you, you can only see the answers here. I'm writing the question here. ABCD is a square of side 10 centimeters. Find the area. Yeah. Find the area of its circumscribed circle and inscribed circle. So this is square ABCD. The circle running through the vertices. Oh my God. Okay, you can see it here. Okay. Okay. Okay, so ABCD is a square, and this circle running through the vertices of the square is the circumscribed circle. And this circle, which touches the sides, which touches all the sides, the circle which is inside the square, touching all the sides of the square is the inscribed circle. So we are given a square ABCD with side 10 centimeters. We have to find the area of the circle that runs through the vertices of the square, which is the circumscribed circle. And also the area of the circle that lies inside the square, touching all the sides of the square. So this one is the inscribed circle. This is the circumscribed circle. Should find the areas of the two circles. Please understand it's here. It's easy. Written the question, online children and children here. Please write the question, then I'll zoom in. You can see the answer clearly. Please write the question and yeah, no, just write the question. I'll tell you what next. Written all of you? Yeah. Now, this is just a repetition. Don't have to write this. Don't write this, okay? Don't have to write this. You don't have to write this. Just draw the circle, meaning draw the figure. Yeah. Work this one first. This is the circumscribed circle. See, please work this one first. This one. And then this is the answer for the next one. Inscribed circle. This one. This is the answer for the next one. Okay. Please do this one first. Draw the diagram. Draw only the first diagram and work the answer. Then the second diagram answer. Am I presenting correctly? Finish the top part. Diagram and above you have the diagram and you must write that clearly the diagonal AC that you should have written. Yeah. Yeah. Now the second one. Finish, darling? No? This is over, right? Yeah. Now take the second diagram. Finding the area of the inscribed circle. Okay. So in the first case, see, in both we have to find the area of the circles, right? So we need the value of r, radius, pi r square is what we have to find. We need the value of r. What is given? The side of the square is given. So here the side of the square is given. Now, what is the, how do you find the radius? See, we have to find the area of the circle, for which we need the radius. Now, what is this? This is the diagonal. This line segment AC has two roles. Now, this line segment AC is the diameter for the circle and diagonal for the square. This line segment AC has two roles. For the square, it is diagonal. For the circle, it is diameter. So if we find the diameter of the circle, half of that is the radius and we can find area. So to find the diameter, we'll find the diagonal of the square. And this is the formula to find the diagonal of the square. The diagonal AC is given by the formula root 2 into A. Root 2A is the formula to find the diagonal of a square. Or you can use Pythagoras theorem. If you should not forget, but just in case you forget the formula, you can just work Pythagoras theorem. This is 10 in a square, you know, all the sides are equal. This is also 10. So by Pythagoras theorem, you can find the length of AC. Same thing you will get. Okay, so AC is 10 root 2. By using the formula or by using Pythagoras theorem, AC is equal to 10 root 2. What's the formula to find the diagonal? Root 2A. Root 2 into side of the square. So this is 10 root 2. That means the diameter is 10 root 2. So the radius is 5 root 2. So area is pi r square. 22 by 7 into 5 root 2 into 5 root 2. In this case, where the circle is inscribed, what is 10 centimeters? It's a diameter. It's a diameter of the circle. Directly, the side of the square is the diameter for the circle. So half of that is a radius, pi r square. All right. Write the question here. This is the next one. ABC is an equilateral triangle. Area of the circle inscribed in the triangle is 154 centimeters square. Find the perimeter of the triangle. Yeah, please work. I'll explain. Just try to understand as much possible. It's very simple. Taken the question, all of you. Yeah. I think you have it in two methods. You can just call this method 1. Yeah, alternate method, yes. Finished? Okay. Then we have to find perimeter. Just complete that alone. Perimeter. Perimeter is 3 into side. Complete that alone. Okay. Okay. Now let's understand the procedure. Okay. Equilateral triangle. What was given? Area of the inscribed circle, right? Okay. What's the area of the inscribed circle? 154. Okay. So pi r square. Pi r square is equal to 154. So what's the value of r? R is equal to 7. R is equal to 7 centimeter or meter, whatever you need. Okay. Now R is 7 meaning A, B, C. What have I called this? M. Huh? Okay. R is 7 meaning OM is equal to 7, correct? Radius is 7 meaning center is O and M is the point on the circumference of the circle. So OM is 7. Now, in an equilateral triangle, the altitude and the medians, the altitudes and the medians will coincide. In an equilateral triangle, we know that every triangle has 3 medians and 3 altitudes. They're the line segments from the vertices to the opposite sides. Scalene triangle. This is the altitude. This is the median from this vertex A to the side BC. Correct? AM is the perpendicular. AM is the altitude from the vertex A to the side BC. But A, say E, is the median from the vertex A to the side BC. What's the property of the median? E is the midpoint. Property of altitude, 90 degrees. AM is perpendicular to BC. This angle is 90. We know it, right? Then similarly, from here, 90 degrees and median, they're different. In a scalene triangle, altitudes and medians, they'll not coincide. Altitude is a line segment. Median is a different line segment. They'll not coincide. In an equilateral triangle, the altitudes and the medians will coincide. That means if this is the altitude, that itself is the median also. If this is the altitude, this is the median also. Altitude, so 90 degrees. But the same thing is the median. Altitude, median. In an equilateral triangle, the altitudes and the medians coincide. So which means this point, what's the point of concurrence of the altitudes called? The point where the altitudes meet is called? The point of concurrence of the three altitudes of a triangle is called the orthocenter. And the point of concurrence of the three medians of the triangle is called the coordinate geometry. We just finished.
Centroid, ma'am.
Centroid. Centroid. Was that Tanishka or Swati? One of your voices.
I'm Swati, ma'am.
Swati. Very good. Yeah. So the point of concurrence of the altitudes is called the orthocenter. Orthocenter. And the point of concurrence of the medians is called the centroid. No, all of you visualize triangle. Three altitudes. The three altitudes will pass through the same point. That point is the orthocenter. Same triangle, three medians. They'll also pass through the same point. And that point is called the centroid. Where the medians meet, centroid. Where the altitudes meet, orthocenter. Now, in an equilateral triangle, the medians and the altitudes will coincide. So the orthocenter and the centroid both is the same point. In an equilateral triangle, this is the orthocenter, this is also the centroid. This is the median, this is the altitude. This is the median, this is the altitude. This is the median, this is the altitude in an equilateral triangle. So it will be 90 degrees here plus this is the midpoint. 90 degrees plus midpoint. 90 degrees plus midpoint. So this is an equilateral triangle. So this is 90 degrees. Also, if you learn the chapter circles, you know that the radius is perpendicular to the tangent at the point of contact. This is the radius, OM is the radius, and BC is the tangent. So this is 90 degrees. This is 90. Okay, so where are we now? We are given the, coming back to this. So we are given what? The area of the inscribed circle. And we have to find the perimeter of the triangle. There are two plane figures here. One is circle, the other is triangle. For the circle, we are given the area. So from that, we can find the radius. But you have to find the side of the triangle and find its perimeter. You have to find the side of the triangle and the perimeter. To find the side of the triangle, we are finding the altitude of the triangle. To find the side of the triangle, we are finding the altitude of the triangle. How? See here. Now, since AM is the median, O is the centroid, and we know that the centroid divides the median in the ratio 2:1. The centroid divides the median and the ratio 2:1. Coordinate geometry. AO is 2 parts, OM is 1 part. AO is 2 parts, OM is 1 part. So what is OM? OM is how much? 7, radius 7. But how do you express OM? OM is 1 part out of 3 parts of AM. 1/3 of AM is 7. OM is 1 part out of 2 plus 1, 3 parts. This is just general maths, nothing. OM is 1 part out of 2 plus 1, 3 parts of AM. See, 1/3 of AM is OM. 2/3 of AM is OA. See, if you feel not comfortable, then what you should do is then you should just work with the ratio number. See. Okay, if you don't want, meaning if you're not able to write this directly, then let AO be 2x. What is OM? X, because the ratio is 2:1. That's because O is the centroid. Because AM is the median. O is the centroid. AO is 2 parts, OM is 1 part. So 2x and x. So then what is AM? 3x. 3x. AM is 3x, right? So now, well, how do you express OM in terms of AM? How do you express OM in terms of AM? OM is equal to, OM is what? X. What is AM? 3x. So what is OM? 1/3 of AM. OM is x, AM is 3x. AM is 3 times OM. OM is 1/3 of AM. Here, OM is x, AM is 3x. So what is the relationship between OM and AM? AM is 3 times OM. OM is 1/3 of AM. That's what I wrote here. OM is 1/3 of AM. So the radius OM is equal to 7. OM is 1 out of 3 parts of AM is equal to 7. So AM is equal to 7 3s are 21, whatever unit children, centimeter. Now this is the altitude. This is the altitude of the equilateral triangle. How do you find the altitude? √3/2 into side is the altitude, which is 21. √3/2A is equal to 21. So A is equal to 21 into 2/√3. So we found A. A is the side of the equilateral triangle, and then find the perimeter. We'll do it again. See here. Very simple. Maybe certain things are new, so it might seem difficult. It's not. Triangle, equilateral triangle in circle. We are given pi r square is equal to 154, and we found r is 7. This is the center of the circle. Radius, triangle ABC, OM. So we know that OM is 7. Okay. Now this is the altitude. AM is the altitude for the triangle. AM is also the median of the triangle. Now we'll first use median. Okay. So O is the centroid. So AO is to OM is 2:1. So OM is OM. We have OM is 7, right? So what is OM? It is 1/3 of the total AM, which is 7. OM is 7. That means 1/3 of AM is 7. Even otherwise, it's easy, children. See, this one is 7, right? 1 part is 7. So how much is 2 parts? 14. So total is 21. OM is 1 part, that is 7. So what is this 2 parts? 14. So what's the total? 14 plus 7, 21. That's what we are working here. Okay. So AM is equal to 21. Now AM is the altitude, because in an equilateral triangle, altitude median coincide. So now AM is altitude. And what's the formula to find the altitude of an equilateral triangle? √3/2 into side. Area is √3/4 into a square or side square. This is area. √3/2 into side, not √3/4. √3/2 into side is equal to 21. So you can find the side of the triangle and then the perimeter. Okay. There's one way of doing it. The other way of working is when you join this OB, when you join OB, now you know this is 90 degrees. You know this is 90, radius perpendicular to tangent, or because this is the altitude, it's 90 degrees, whatever. Okay, it's 90 there. Now when you join, what this is called the what? In center. When you join the in center to the vertex, you know, this line segment will bisect this angle. So again, this might sound like how and why, but because constructions are not a part of the CBSE syllabus at all. That's the worst part of the syllabus. So now I have to tell you theoretically. Otherwise, in classes 6 and 7, in the ICSE syllabus, we learn how to construct circumcircles and incircles. So that way, by visually you see the properties. By construction, so anything visual like bar graph, pie chart, it's interesting and easy to understand also, right? Similarly, constructions are so important, but construction now it's completely removed from the syllabus. Okay. Educators know better than a teacher like me, so I have no comments, but I always prefer this syllabus over CBSE because see, it's so theoretical now. Maths has become theoretical. Now, when you join, this is the in center, because this is the in circle, this is the in center. When you join the in center to the vertex, when you join the in center to any of the vertices, that line segment will bisect this angle. So this is 60 degrees. Why? Because equilateral triangle 60. Now when you join like this becomes 30, 30. Now here you have a right triangle with one angle 30 degrees and radius 7. That is OM 7. That is you have a right triangle with this side 7 and this angle 30 degrees. Now what do you want to find? You want to find this one. You want to find BM by using trigonometry. You want to find BM. And since you know M is the midpoint of BC, why is M the midpoint? Because M is the median. So M is the midpoint. Because M is the midpoint of BC, it's enough if you find BM. Double it, you'll find MC. I'm sorry, double it, you'll find BC. And then perimeter. This is the other way of doing it. I'll repeat this. This is using the property of in center. When you join the in center to any vertex, that line segment will bisect that angle. O is the in center. B is the vertex of the triangle, one of the vertices of the triangle. When you join OB, this angle is 60 degrees. Because you're joining the in center to B, the angle is bisected. So 60 becomes 30, 30. So now we have a right triangle, OMB. This is 90. This one we found because pi r square is equal to 154. We found this one. We found OM is 7. Now this angle is 30 degrees. Use trigonometry and find BM. Double BM to get BC. So that's the side of the equilateral triangle. And then find the perimeter. All right. That's what is here. Please work this alternate method. Finished? See, pi r square is 154. Then you have to work 22 by 7 into r square is 154. R is 7. And this is the theorem, radius perpendicular to tangent in circles. Okay. Then we go to the next one. Yeah. This one. Okay, write down the question. I've zoomed in, so I can't write. Don't write what's here, what you see here. Just write down. A regular hexagon, a regular hexagon is inscribed in a circle of radius 28 centimeters. So a regular hexagon is inscribed in a circle of a radius 28 centimeters. Find the area of the circle outside the hexagon. That's the question. Find the area of the circle outside the hexagon. Find the area of the circle outside the hexagon. So in the solution, draw this figure. This is, don't try it all. Let me just type it out. Yeah, draw the figure. Okay. So what are we supposed to find? We are supposed to find the area of the circle outside the hexagon. So we have to find the area of you have to find the area of the circle, but outside the hexagon. So this region, you need to find the area of these portions. You should not find the area of the full circle. Area of the circle which is outside the hexagon. So these are the portions of the circle outside the hexagon. You must find this, which is clearly the area of the circle minus the area of the hexagon. Area of the circle minus the area of the hexagon. Okay. So what's the formula to find the area of a hexagon? A regular hexagon is made up of 6 equilateral triangles. A regular hexagon is made up of 6 equilateral triangles. The area of an equilateral triangle is √3/4 into side square. So 6 equilateral triangles make this regular hexagon. So 6 into √3/4 a square. So please work. It's all there. Don't write the area of the design, okay? Just stop that. Don't write area of the design. Write area of the circle outside the hexagon. 1 minute. Let me just correct that. 1 minute. Take that instruction. √3 is equal to 1.7. I didn't tell you in the question. It's given. Take √3 as 1.7. Please include this in the question. √3 is equal to 1.7. Okay. See, in the question, it was only given that the radius of the circle is 28, right? But how do you know that the side of the hexagon is also 28? In the question, it's given that the radius of the circle is 28. Then how do you know the side of the hexagon is 28? The question is a regular hexagon of, okay, a regular hexagon is inscribed in a circle of radius 28 centimeters, right? Read the question from your book. Yeah, we only know that the radius is 28. Now, how do you take the side of the hexagon as 28? Because it's an equilateral triangle. Because this one is an equilateral triangle. So this is the radius. OA is a radius or OB is a radius. But since it's an equilateral triangle, all the sides are equal. So the side of the hexagon is also 28. Am I clear? We are only given the radius of the circle. Radius is 28. So center to any point of the circumference. OA is 28. OB is 28. But we have marked this also as 28. No, that's because this one is an equilateral. Because we understood that a regular hexagon is made up of 6 equilateral triangles. See, these are the triangles. These are the 6 equilateral triangles. All these are equal. This total angle is 360, no? It's 360. So it will be 60, 60, 60, 60, 60, 60. This one is an equilateral triangle. All right. So if this is 28, this is 28, this is also 28. Correct? Okay. So a regular hexagon is made of 6 equilateral triangles. Area of regular hexagon is equal to 6 into root 3 by 4 into side of hexagon square. Side square, so side of hexagon square. Area of regular hexagon is equal to 6 into root 3 by 4 into side square. Okay, so you can see I've cancelled 6 and 4. So we have 3 into root 3 by 2 into 28. Actually, side of hexagon was not given, only radius was given. Because a triangle is an equilateral triangle, the side of the hexagon is also 28. So you find area of the hexagon, area of circle, pi r square. You know the radius. So the required areas, area of the circle minus area of the hexagon. Fine. Completed online, children?
Yes, ma'am.
Okay. Yeah. Write on the question. Yeah, a circle is inscribed. A circle of radius 28 centimeters. A circle of radius 28 centimeters is inscribed in a regular hexagon. In a regular hexagon, that's all. A circle of radius 28 centimeters is inscribed in a regular hexagon. Find the area of the hexagon outside the circle. Find the area of the hexagon outside the circle. Please work and then we'll discuss. See, what to work is, what should you find? You should find the area of the hexagon outside the circle. So how do you do it? It's the area of the hexagon minus the area of the circle. For the circle, we know the radius. Area of hexagon minus area of circle. For circle, we know the radius. So we want to know the side of the hexagon. How do you find the area of the hexagon? 6 into root 3 by 4 into side square. We have to find the side of the hexagon, AB. That's what we're finding. See, once you find AB, then you can find the required area. So how to find AB is using trigonometry. And if you want to use trigonometry, you should take a construction, draw something perpendicular, or you should find some 90 degrees triangle. Yeah. What? Finished? Yeah, then you can continue. Now we've got the side of the hexagon, right? So only find the area of the hexagon. 6 into root 3 by 4 into side square. The side is 56 by root 3. I think I didn't rationalize because anyways it's going to be side square. So 56 by root 3 into 56 by root 3. So Yeah, you don't have to rationalize. Okay. Done writing, online children? Let me show you the next slide. Please check if you got this answer. Okay. Completed? Okay. So here, I'm not trying to draw this figure. So I'll just use the figure here. What is given? The radius of the circle is given, right? Okay. So we are given, is OA the radius, children? Is OA the radius of the circle? Is OA the radius of the circle? No. Is OB the radius of the circle? No. OM is the radius. OA, A and B are points not on the circumference, outside the circle. A and B are points outside the circle. So OA, OB, not radius. Oh, that is why OM. M is the point of contact of the tangent AB. M is the point of contact of the tangent AB with the circle. Okay, so we joined OM. When you join the point of contact and the center of the circle, that's a radius, right? And that radius will be perpendicular to the tangent. That's how 90 degrees. OA, see, A and B are points outside the circle. So OA and OB are not the radii of the circle. That's one thing. Now, how to mark then? A radius is given 28. I want to mark 28 in this figure. Where to mark 28? What is AB? Tangent. What is M? Point of contact. Join OM. Okay, M is a point on the circle. So when you join OM, OM is a radius. And we know that OM is perpendicular to the tangent AB at M. Okay. So now we have a right triangle. OAM is a right triangle. We know why it's a right triangle. Where OM is the radius, 28. And this angle at the center, because that's made by the hexagon, right? This point here at the center. Okay, that the center of the circle also will be the center for the hexagon, where the sum of the angles is 360. So what's the angle here? 60. Now, in these two triangles, you can show that they are congruent. You can show that these two triangles are congruent. So the 60 becomes 30, 30. So in this right triangle, this angle is 30 degrees. And this side OM is 28. So what do you want to find? You want to find AM. So that you can double and get M, so that you can double and find AB, which is the side of the hexagon. And then 6 into root 3 by 4 into side square, you can find the area of the hexagon. We know radius of the circle, no? So we can find area of the circle. What do you want? You want the side of the hexagon, so that you can find the area of the hexagon. Now the area of the hexagon minus the area of the circle is the required area. So how do you find the side AB of the hexagon? For that is what is all this procedure. So join OA, OB, and OM. OM is the radius. This central angle is 60 degrees. These two triangles are congruent. So this angle is equal to this angle. So 60 becomes 30, 30. So in right triangle OAM, OM is 28. You need to know one angle and one side at least. You need to know two things in a right triangle to use trigonometry. You need to know two things in a triangle, in a right triangle to use trigonometry. So we know two things, 30 degrees and OM. And you want to find AM. So connect using the appropriate trigonometric ratio. So cos or secant. Find what have I found? Oh, I found OA. Is it okay? It's an equilateral triangle. Now don't tell me what is this. You're explaining something. Okay, I didn't see the working there, children. Sorry. Okay, I found OA, but it's the same no, because it's an equilateral triangle. So all the sides are equal, right? So please excuse me. I didn't see what I worked there. I was telling you to find AM and double to get MB, children. That's also fine. You can use trigonometry to find, but I didn't mention the trigonometric ratio there would be tan 30 is equal to opposite by adjacent. Now in the cos update path cos in solitary. I just didn't notice what I had worked here. Now in the cos path cos in tech. Okay, I was telling find AM, no? So in this right triangle, we know 30 degrees and OM. How to find AM? Tan 30. Tan 30 is opposite by adjacent. So you'll find AM and double it to get AB, which is the side of the hexagon. Okay, here I found OA. You can find OA also. Because OAB is an equilateral triangle, OA is nothing but AB. All sides are equal. So anything you can find. I didn't confuse you, right? So like this, we find the side of the hexagon. And then, area of hexagon minus area of circle is equal to area of the required region. Okay, next one. All of us finished online, children?
Yes, ma'am.
Okay. Yeah, try this one. Yeah, what's the answer? 282. Online children?
82 centimeter.
282, huh?
Yes, ma'am.
Okay. What about Swati, Niveda, and Adagammai? Okay.
Ma'am, I did a mistake, ma'am. Have to correct it.
Okay. Fine. So, what makes the perimeter of this, tabletop? What makes the perimeter? The length of this line segment plus the length of this line segment plus the length of this arc. Add all the three to get the perimeter of this tabletop. Okay. இங்க வந்து சேர் போட்டு உட்காந்துக்கிற இடம் போல இருக்கு. அதனால தான் அந்த கேப். Okay, so this is a top of a table. Top of a table. இங்க தான் நீங்க சேர் போட்டு உட்காந்துப்பீங்கன்னு நினைக்கிறேன். So you need to find the perimeter of the tabletop. So that is OA plus OB plus the length of this arc. OA is 42. OB is 42. So we just need to find the length of this arc, which corresponds to the sector angle 270 degrees. The length of this arc corresponds to the sector angle 270 degrees, not 90 degrees. 90 degrees is for this arc. 270, 360 minus 90, 270 is for this arc. So we need to just find the length of that arc. Length of arc. Length of arc in the major sector. Or length of major arc. Length of major arc is equal to, see, you write theta by 360 or 360 minus theta, whatever, but be careful. See, the angle is 270. Okay, so 360 minus theta by 360 into 2 pi r, because it is perimeter. That is 360 minus not 270 minus 90, or you write 270 directly. Minus 90 by 360 into 2 into 22 by 7 into 42. So this is 270 by 360. 7 1 the 7 6 into, how much is this? 12 into, okay, let me just write it like that for now. 2 into 22 into 6. So 93 times, 94 times. So 2, what is this? 22 into 9, no? Okay, what's 22 into 9? 198. Okay, 198 centimeter. Okay, so perimeter is equal to, the required perimeter of the tabletop is equal to OA plus OB plus length of arc. So that is 42 plus 42 plus 198, which is, sorry about my addition, plus 84, 282. Centimeters. All right. Okay, next one. This is your next question. Taken the question, all of you? That was marked I think. I didn't notice that. I took it as O. The letter I didn't notice. I took it as O. Maybe you can correct that in the figure. This one, no, you take it as O, don't take it as I. You have to find the area of the shaded region, which is the area of the triangle minus area of the circle. So find the area of the circle and complete the answer. I haven't completed. Pi 3.14. Take pi as 3.14. It's given in the question. What's the answer? Sorry? 11.4. Renu, your answer? What's the area of the shaded region? Online children? Oh. Yeah, correct. What's the area of the circle? 12.57. Area of the circle, I'm sorry, its final area is 11.428. 80 by 7, I go. Okay, that's fine. Oh, I didn't take pi as 3.14. I've taken 22. 11.4. Okay. So here what we do is, okay, so what's the question? We have to find the area of the shaded region. How do we find that? Area of the triangle minus area of the circle. Area of the triangle minus area of the circle. Triangle area you can find because it's a right triangle. It's a right triangle. I hope you all notice that 90 degrees there. It's a right triangle. It's a right triangle. So you can find the missing side using Pythagoras theorem and then half base into it, you will get the area of the triangle. Or you will be able to find the area of the triangle. For circle, you need the radius. Circle, you need the radius. So here what we do? We join. I've taken this as O children. I didn't notice the I. It's called an I because it's in center. In center I. Okay. So join OA, join OB, join OC. Let this be the point of contact. Let D, yeah. Let D be the point of contact of the tangent BC. Let E be the point of contact of the tangent AC. Let F be the point of contact of the tangent AB. Join OD, OE, OF. Radius tangent 90 degrees. Radius tangent 90 degrees. Radius tangent 90 degrees. So we have divided the whole triangle into three smaller triangles. We have divided the whole triangle into three smaller triangles. Area of triangle AOB plus area of triangle BOC plus area of triangle AOC. I'll remove the others once again. I'll just do it again. See here. We first actually divide the whole triangle into three smaller triangles by joining O to A, by joining O to A, O to B, and O to C. So we first divide the whole triangle into three smaller triangles. Okay, so area of triangle AOB plus area of triangle BOC plus area of triangle AOC is equal to area of the whole triangle ABC. Okay, it's equal to the area of the whole triangle ABC. Now to find the areas of these triangles, we need altitude for area of triangle AOB. Area of triangle AOB, you want altitude. That's why you mark off the points of contact. D, E, F, because you want altitudes. Because you're going to use a formula half base into height. Base we know for every triangle, we know the base. 1 minute. For every triangle, we know the base. For triangle AOB, AB is the base. For triangle BOC, BC is the base. And for triangle AOC, AC is the base. Now we want the respective altitudes. That's why we mark D, E, F, the points of contact, and we join O to D, O to E, and O to F. Now all this is 90 degrees because radius perpendicular to tangent. This way we've got the altitudes, and this is R. The altitudes are R. The altitudes. Sorry, yeah, they are the altitudes of the triangles. radius of the circle. Okay. Correct? OD, OE, OF is equal to R. Okay. Now what's the area of triangle AOB? Half into base AB, 6, into altitude, R. So this is nothing but 3R, plus half into base, 10, BOC, BOC. So BC is the base 10, altitude, R. This is 5R, plus half into side AC, Pythagoras theorem, 8 into R, 4R, 4R, is equal to area of the triangle ABC. You can find the area of the triangle ABC using half base into height. Half into 6 into 8. Half into 6 into 8, 24. So like this, you can find R. 3R plus 5R plus 4R. 12R is 24. R is equal to 2. We found the radius. This is the idea. This is the method you use to find the radius in a situation like this. So we found the radius. Now find the area of the circle. Then the area of the triangle minus area of the circle is the area of the shaded region. Right? Any questions? Yeah, no problem. 11.4, yeah, 4 to 8. Correct. But if it's given, take 3.14, you have to take 3.94. Yeah, this is the next question. All of you completed this? I haven't completed the answer. The final answer is 11.4. Online children, final answer 11.4. Yeah, next one. We'll mark this and wind up the class for today. For the answer, Yes, finished. Yeah, children. Online children, Swati, Tanishka, Niveda, and Aragamai. Where are we stuck actually? Prema? No. What help you need? I mean, let me see what you're working. Come here. You come here, Akshata, or one of you come here first. Yeah, boys. No, quadrant is not a quadrilateral. Quadrant is one part of a circle. This is a quadrant. You don't work with this and find. Then what do you? Okay, this is two. This is correct. Then, yeah, how can you find area? Oh, you found then need theta by 360 into 2 pi r. We could do. No, L is not 25. No? Oh, here you put. Oh, I saw only this one. Oh, you added that here. Oh, you're not getting the value correctly. You're stuck there. Same thing, huh? Huh? You got it. You both have written that 2r plus L correctly. Let me see. I don't know if my number is. Let me just check. Yeah, I have the answer for this. Yes, please check. Let me just tell you something before that. So, a quadrant is a quarter of a circle. A quadrant is a quarter of a circle. 1/4 of a circle. Okay, so like circle, when you divide that into 4 equal parts, each one is a quadrant. This is a quadrant. Okay. Okay. So now the perimeter of a quadrant, perimeter is 25. That means this one radius plus this one radius plus the length of arc is equal to 25. R plus L is equal to 25. 2R plus L. Well, how do you find the length of arc? How do you find this length of arc? 90 by 360. 90 by 360 into 2 pi r is equal to 25. R plus R plus, no, quadrant is this figure. Okay. So how do you find the perimeter of the quadrant? R plus L is equal to 25. That's a given. 2R plus L is 90 by 360 into 2 pi R is equal to 25. So 2R plus 1's a 4's a, then 2, 1, 2 times. So how much will you get? Pi R by 2 is it? Pi R by 2 is equal to 25. So 2R plus, this is what, 22 by 7. So 22 by 7 into is equal to 25. So 2 and 22 gets cancelled, 11. So 2R plus 11R by 7 is equal to 25. We need to continue like this. And I have R7. And area of the quadrant is 1 by 4 into pi R square. Please complete this now, all of you. See, I've taken 2 pi R by 4. 1 minute. I've taken 2 pi R by 4. That is 2 pi R is the total length by 4. See, it's the same thing. Even if you take 90 by 360, finally you get 11R by 7 only. See, here also we get 11R by 7. Same thing, children. Both are the same. So why did you, like, what was the mistake? ஏன்னா கன்ஜஸ்டடா ஒர்க் பண்றதால தப்பு பண்ணிட்டீங்க. See, the length of this full circle is 2 pi r. So from here to here will be 2 pi r by 4, the length of arc. The length of arc in the quadrant. The full thing is 2 pi r. So in the quadrant, you'll have 1/4 of it. So 2 pi r by 4. Or you can also use a formula theta by 360 into 2 pi r. Get the same thing. Completed? Completed, all of you? All right, children. So that's it for today's session. Thank you so much. Good night, and online children can leave the call. Good night.
Thank you, ma'am.
Thank you. Good night.